In general, when you're solving a linear equation, we want to gather all x's on one side and all non-x's on the other side. So I might start by subtracting 4x from both sides. Oops. So those cancel, and we get 7 equals 5x minus 13. Then what do you want to do? Add 13 to both sides, so we get 5x equals 20, which means that x equals 4. And you got that by dividing both sides by 5. So the solution set is the number 4. Okay, so this is just this is a little quirk of your textbook. They like you to put your solutions in a set, right, using the curly brackets, and list all your solutions. If it's a quiz or a test and you don't do that, I'm not going to take off points. I'm just trying to like keep with the notation of the book, so if you go read it, you're not going to be like, why are they doing that? All right, so let's look at part B here. We have 3 times the quantity x plus 2 equals 10 minus 5 times the quantity x minus 4. So what do you want to do first in this one? Distribute, yeah. So we want to remove parentheses if they are there by distributing. So I'm going to have 3x plus 6 equals 10. And I'm going to distribute a negative 5 here because of the minus sign. So I have minus 5x plus 20. Then we'll combine like terms, move everything to one side. So I'm going to add my 5x to both sides. So I have 8x. And 10 and 20 is 30. And I'm going to subtract 6 from both sides. So I have 24. And then if I divide both sides by 8, we get 3. So x equals 3. So that is my solution set. In curly bracket, the list of all values that make that equation true is just the number 3. Okay, and it is a good habit to check your answers, because when you're solving an equation, there's no excuse to get it wrong, to unknowingly get it wrong, right? You can always go back, plug your answer in, and make sure that the equation is true. So if I plug 4 back into this original one, I get 4 times 4 plus 7. And I want to know, does that equal 9 times 4 minus 13? Well, 4 times 4 is 16, plus 7 is 23, and 9 times 4 is 36, minus 13 is 23, so they are equal. And we should probably do it for the other one too, but I'm not going to. All right, so I'm going to look at that other equation 1b, and we're going to try to use our graphing calculators to come up with the solution this time. So our calculators can provide us with numeric and geometric meanings to the solution x equals 4. So I'm going to pull up my calculator. And I'm going to put each side of the equation, the left side and the right side, into y equals separately. So in y1, I'm going to put the left side of the equation, 3 times x plus 2. And in y2, I'm going to put the right side of the equation, 10 minus 5 times x minus 4. So step 2, I'm going to go to the table, and I'm going to look for values of x for which the y values are the same. So I can do it in 2 ways. I can go to the table and try to find x values that an x value that gives the same y value. So I go to table, second graph, and we have the option of typing in any x values, so we have to do some guessing here. So maybe I'll do like 1, 2, 3, 4, 5, 6, 7. Right. What was the solution to the first one? 4? Why isn't that working? Oh, because we're looking at the second equation, right? Okay. Looking at the second equation, it's got a solution of 3. Right? We already know that because we did it algebraically. All right, when we look at this table of values, I just picked some random x values, and you just have to do some guess and check here. You were looking, y1 represents the left side of the equation, and y2 represents the right side. So left side and right side. And we're looking for an x value. What x value makes the left side and the right side the same? Right? So you look down the y1 and y2 columns for two y values that are the same. 15, yeah. And when they're both 15, the x value is 3. So that's how we find the solution numerically, right? So if we type in 1, 2, 3, 4, 5, we have 9, 12, 15, 18, 21, and y2 gives me 25, 20, 15, 10, 5. And we say, oh, okay, look, right here, when x equals 3, the left side and the right side of the equation give the same value. Okay, so 3 is a solution. All right, and then I'm going to do a more graphical method. Rather than using the table, I'm going to use a graph. So I already have the left side and the right side in y1 and y2. And I'm just going to press zoom 6, because remember that gets you a standard viewing window. Negative 10 to 10, negative 10 to 10. And I want to find the place where those two graphs intersect. And it looks like it's not quite in my window. So I'm just going to adjust my viewing window a little bit. Maybe I'll go negative 5 to 20. Negative 5 to 20. And now I can see where they cross. All right, so if I copy this graph down onto my paper, to find the solution, I'm going to use the intersect feature, right? And the solution of where the left side and the right side are the same is the x coordinate of this intersection point. So I'm going to have my calculator find it. So you go second, calc, choose option 5, intersect. And then you have to tell it the first curve, the second curve, and a guess. So when you come back to the home screen, it's prompting you. The cursor is flashing somewhere. It's not on my... Should have it soon. Okay, there's my cursor. So it's your cursor should be on one of your graphs, and it's asking you, is this the first curve? Is this one of the curves that we're looking for the intersection of? And you say yes by pressing enter. And then the cursor jumps to your other curve, and it says, is this the second curve? And you say yes. And then it asks you to guess, and all you have to do is put the cursor anywhere near the intersection point, and it will find it. It says it's at 3, 15 are the coordinates of the intersection. So this point here is 3, 15, and x equals 3 is the solution to the equation. And 15 is what you get when you plug 3 into both sides and you see that they're equal. They both equal 15. So everyone okay with linear? All right. So now we're going to deal with some linear equations with some fractions. So let's say I have this equation, we've got some fractions in it, x plus 1 over 4 equals 1/6 plus 2 minus x over 3. What would be the first thing you would do? Common denominator. Anyone else have a different approach? Sure. Yeah. Yeah, so we could, I think you two are describing a similar thing where you clear the fractions. Using multiplication. Okay, good. So would you agree in general that it's easier to solve linear equations if they don't have fractions in them? Yeah, I much prefer not dealing with fractions. Is there a way to solve linear equations that contain fractions without having to deal with them? Yeah, it's very exciting. We can take anything that has fractions in it and we can get rid of them. Any equation with fractions and you can get rid of them. So it makes our life a little bit simpler to be able to clear an equation of fractions. So here's our original given equation. We're going to multiply everything on both sides of the equation by what? What do you think? Just 12. Yeah, so if you were dealing with an expression, you would use 12 over 12 because you don't want to change it. But when you're dealing with an equation, you can multiply by anything you want as long as you multiply both sides by it. So I can use 12. But how'd you come up with 12? It's the common denominator of all three of those fractions. It's the least common multiple. So I'm going to multiply both sides by 12. All right, so on the left, I have 12 times x plus 1 divided by 4. How does that simplify? The 12 over the 4 you can simplify before it's nicer to do that before you distribute. So the 12 over the 4 reduces, right? 4 goes into 4 once and it goes into 12 3 times. So on the left side, I have 3 times x plus 1. Okay, and then I'm going to use the distributive property, and I have to multiply both of these fractions by the 12. So I end up with 12 times 1/6 plus 12 times 2 minus x over 3. I'm a little off here, sorry. Okay, so now I am going to distribute everything. Okay. So I have 3 times x plus 1, that gives me 3x plus 3. Then on the right, I'm going to multiply each of these terms by 12. What is 12 times 1/6? 2, yeah, because 12 divided by 6 is 2. And here I have 12 times 2 minus x divided by 3. What do I end up with? Yeah, before you distribute, you end up with 4, right, times 2 minus x. Because you can say 3 goes into 3 once and into 12 4 times. The 12 over the 3 reduces to 4. Okay, so if and now I have no fractions, right? My fractions are gone. I can do a little happy dance and then continue solving an easy linear equation. Right, so I have 3x plus 3 equals 2 plus 8 minus 4x. And if I finish solving, I've got 7x equals 7, so x equals 1. Isn't that amazing? Getting rid of fractions. So I suppose we should check the solution. It's a big, bold, capitalized suggestion that I do it. So I go back and I say, oh, right, it was x plus 1 over 4. So 1 plus 1 over 4. Does that equal 1/6 plus 2 minus x over 3? 1/6 plus 2 minus 1 over 3. All right, well, 1 plus 1 over 4, that reduces to 2 over 4, or a half. And here I have 1/6 plus 1/3. Does that add up to a half? Yes. So yeah, those are the same. So we just solved a rational equation that had constants, just plain old numbers in the denominator. We can do the exact same process when our denominators have variable expressions in them. So things like 7 over 2x minus 5 over 3x equals 22/3. Okay. These are just some examples. So the procedure for solving them is very similar to the one we solved in question 4. We still multiply both sides of the equation by the lowest common denominator. However, there's one very important difference. We have to exclude any values of the variable that make the denominator 0. So we want to solve and check these rational equations. So I have 7 over 2x minus 5 over 3x equals 22/3. So I need to figure out what the common denominator is. 6x. Yeah. I want all the denominators to be the same. So they have to all, this one's got a 2x, and this one has a 3 and an x, and this one has a 3. So they all need to have a 2, a 3, and an x. So this 7 over 2x is missing a 3, so I'm going to multiply, or actually no, I'm going to, if my common denominator is 6x, I'm going to multiply both sides of the equation by 6x. So I have 7 over 2x minus 5 over 3x equals 22/3. Multiply both sides by 6x. So on the left, I have to distribute this 6x to both terms. So I end up with 6x times 7 over 2x minus 6x times 5 over 3x. And then on the right, I end up with 6x times 22/3. Now, before I multiply, I'm going to cancel anything that I can cancel. Just makes all the arithmetic easier. And it might help you when you're working with fractions, whenever you have a fraction, an expression that's not a fraction, to put it over 1. Some people find that helpful, and some people don't. So do whatever works for you. All right, so I have 6x over 1 times 7 over 2x. So I have an x on the top, an x on the bottom. Those cancel. And the 6 over 2, that would reduce to what? 3. So the 2 goes into 2 once and goes into 6 3 times. And that's the best I can do for reducing there. And then the next term, I have an x on the top and x on the bottom, and those cancel. The 6 over the 3 reduces to 2. Yep. And then on the right-hand side, just the 6 over the 3 reduces. So after I've done all this canceling, this first term is a 21. I am just left with a 3 times a 7 in the numerator. And my next term is 10. All that I'm left with is a 2 and a 5 in the numerator. And that should equal 2x times 22, which would be 44x. And now I have a linear equation, which we know how to solve. So I'll just, 21 minus 10 is 11. So x equals 4, right? Oh, right. 11 over 44, which is 1/4. Now I just have to make sure that whatever I get as a solution, if I plug it back in, won't put a 0 in a denominator. Right? Do I have to worry about that at all? No. 2 times a fourth is a half, and 3 times a fourth is 3/4, and this denominator is always 3, so I don't have to worry about having a 0 in a denominator. All right, let's look at the next one. 5 over x plus 2 plus 3 over x minus 2 equals 12 over x plus 2 x minus 2. What is the common denominator? X plus 2 x minus 2. Yeah. X plus 2 x minus 2. So I'm going to multiply both sides of the equation. So I've got 5 over x plus 2 plus 3 over x minus 2 equals 12 over x plus 2, x minus 2. And I'm going to multiply both sides of the equation by x plus 2, x minus 2. All right, so on the left, I have to distribute this x plus 2, x minus 2 to both of these like periwinkle colored terms, right? Distribute it to both of them. So I have x plus 2, x minus 2 times 5 over x plus 2 plus x plus 2, x minus 2 times 3 over x minus 2. And that will equal x plus 2, x minus 2 times 12 over x plus 2, x minus 2. All right, so now I do the fun part, which is the canceling. So remember, you can think of these guys as over 1 if that helps. And then anytime you have a factor that's the same on the top and the bottom, you can cancel it. So in my first term here, I have an x plus 2 on the bottom and an x plus 2 on top. And in the next term, I have an x minus 2 on the bottom and on top. And in the term on the right, I have x plus 2, x minus 2 on the top and the bottom, and that all cancels. So all I'm left with this first term is 5 times x minus 2. And in the next term, I have an x plus 2 and a 3 left. So 3 times x plus 2. And on the right, I just have a 12. And so I've cleared the equation of all fractions. My denominators are gone. And I could solve that linear equation in my sleep, right? Easy one. So I'll leave that to you to finish solving. It comes out to be 2. Oh, that's a big problem, right? Okay. So let's finish solving it. So we get 5x minus 10 plus 3x plus 6 equals 12. So 5x plus 3x is 8x. Negative 10 plus 6 is negative 4, so I'm going to add 4 to both sides, and I get 16, and I get x equals 2. But if I go back to try to check my answer and I plug a 2 in, what happens? Yeah, the world explodes, right? I put a 2 in, and I end up with a 0 in this denominator and a 0 in this denominator. So x equals 2 cannot be a solution, right? So we say, nope, never mind. When you solve an equation and you do a whole bunch of stuff and you come up with a solution, and when you plug it back in, it turns out to not really be a solution, that's called an extraneous solution. Extraneous, so the root word is extra. It's like an extra solution. So 2 is the only our only solution, and it's really not a solution. So what can we say about this equation? no solutions. So this equation has no solutions. There is no value of x in the whole real number system that will make it true. Yes. Yep. Thank you. Yeah. Okay, so I'm going to let you try the next one, but I'm going to give you a big hint. Before you do anything, factor that denominator. I'll come around and help if you need it. So we have 1 over x plus 1 over x squared minus x. It can be helpful to write down excluded values first. So what values of x can I never plug in here? 0 and 1. Because 1 squared minus 1 is 0. All right. So that's just, sometimes some people do that first, some people do that last. It's just good to keep in mind what your excluded x values are. All right, so if I factor that second term, which was the hint I gave you before we started, we'll call that 5 over 1. What is the common denominator of those three terms? X times x minus 1. If I was going to try to add those three fractions together, that would be the denominator I would use. So I'm going to multiply both sides of my equation by x times x minus 1. All right. So now, on the left side of the equation, I have to distribute the x times the x minus 1 to both of these terms. So I have x times x minus 1 times 1 over x plus x times x minus 1 times 1 over x times x minus 1. And that equals x times x minus 1 times 5. And remember, you can add in over ones if it helps you picture the fractions. Okay, so now we can cancel anything that's the same in the top and the bottom within each term. So here's my first term. I can cancel the x's. And I'm left with just an x minus 1. And then my next term, the entire denominator cancels, and I'm just left with a 1. And then in the last term, nothing cancels. And I'm left with 5x times x minus 1. So I have no more fractions. My minus 1 and my plus 1 cancel here, and I get x equals 5x squared minus 5x. So what should I do now? Add 5x to both sides. Okay, so I would have 6x equals 5x squared. How do I take out an x? If I divide both sides by x, I have to go way back up to the top here. I wrote down those excluded values. X can't be 0, right? Right, and if I divide by an x, I run the risk of exploding the world, right? Because I don't know the solution yet. And if I divide by x and it turns out x is 0, I've made a big mistake, right? So If I knew ahead of time that there's no way x could be 0, then you can divide by x, but I don't know that. So if maybe I'll move the 6x over, so I have 0 equals 5x squared minus 6x. Then what can I do? Pull out an x, yeah, so I end up with x times 5x minus 6. Yeah, can you explain how that works? Why can I set each thing equal to 0 now? Yes, I have a multiplication. Yeah, multiplying two things together. Right. Yes. Can I do that if it's, say, if the left-hand side of that equation said like 1? No. Yeah, it's something special about 0, right? When you have a multiplication problem and you multiply two things together and the answer is 0, one of them has to be 0. That's the only way to get 0 as an answer to a multiplication problem. So either x is 0 or 5x minus 6 is 0. And then we solve this one and we get x equals 6/5. So had we just divided by x up here, it's a very tempting thing to do, right? If we had 6x equals 5x squared, and we divided both sides by x, cancel, 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 we would have gotten 6 equals 5x, and x equals 6/5, right? We would have lost a solution, because, but what? Right. And we know that x equals 0 can't be a solution because you can't put 0 into the original equation. Yeah. So what I would do here is go extraneous solution, because I cannot put 0 into the original equation. So in this case, it would have been okay to do this route, knowing that 0 can't be a solution. Yeah. So this is okay for this problem, because we know x can't be 0. Okay, so we're going to look at a couple little application problems. Section 1-2 of your book opens by looking at the positive effects of humor and laughter on our lives. And we have this graph and two equations that model the average level of depression in response to negative life events for two groups. So one group of people is a low sense of humor group, we'll call them D sub L, and a high sense of humor group, we'll call them D sub H. So we have a formula for each of these that involves some fractions. X represents the intensity of a negative life event. So 1 being a low intensity negative event, and 10 being a really intensely negative event. And then D is the average level of depression in response to that event. So on the x-axis, we've got how bad the event is, right? And on the y-axis, we've got a depressive response. And then high humor group and low humor group, red and blue. So what is a quick, clear conclusion you can get from that graph? Yeah, the high humor group has a much lower depressive response than the low humor group. Yeah. Okay, so we want to figure out the intensity of an event X. So what intensity for the low humor group would cause an average level of depression of 9? So I want you to discuss in your groups. We're looking for an X. We're looking for what intensity would cause a depressive response of a 9. And we're looking at the low humor group. All right, so let's go through it together. So I just wrote down the equation for the low humor group, right? Because they told us we're dealing with the low humor group, so just copy down the equation. All right, they're asking us to determine the intensity x. So x is what we're going to be solving for, right? Because they're asking us to find out what that is. Oh, for the low humor group and the high humor group. I didn't see that. Okay. So if the average level of depression is 9 in response. So I want to replace the D, which stands for depression level, right, with a 9. So I have 9 equals 10/9 x plus 53 ninths. And then I'm going to set up a similar equation for the high humor group, D sub h. It was 1/9 x plus what? 26 ninths. Okay. And in the same thing here, I'm going to replace the depression level with a 9. And we're going to determine for the two different groups what kind of a life event would cause a depression level of 9. So I have to solve each of these two equations. Any ideas? We'll start with the low humor group. Katrina. Multiply both sides by 9. So what was it that prompted you to do that? Denominators of 9. So you're thinking, okay, I have denominators of 9. If I multiply by 9, I'll get rid of the denominators. All right, so on the left here, 9 times 9 is 81. And on the right, I need to distribute that 9 to both terms. And when I distribute it to this first term, it's going to cancel with the 9 in the denominator. I'm going to be left with 10x. And when I distribute it to the second term, it cancels with the 9 in the denominator, and I have plus 53. So now this is just a linear equation I have to solve. So 10x, that's 81 minus 53. 28. Divide 10, both sides by 10, and we get x equals 2.8. So for the low humor group, a life event on the scale of negative life events, a 2.8 would cause a depressive response of a 9. Let's see what it would take for the high humor group to get that same response. So this equation also has 9s in the denominator, so I'll use the same approach, multiply both sides of the equation by 9. Okay, 9 times 9 is 81. 9 times 1/9 x is just x, the 9s cancel. And then 26 over 9 times 9, the 9s cancel, and I get 26. So x equals 81 minus 26 is 55. Yeah, so that is a way, way more intense event, right, than 2.8. Yeah, to cause a depressive response, the same depressive response as the low humor group. Yes. Yeah. You can write it as x over 1. Is that? I mean 1 over x. Oh, okay. There you go. Yeah, that x is actually in the numerator. Yeah. So your homework for the weekend is to do something that makes you laugh. Right. Yeah, your math homework would definitely qualify. Do you have a question, Tenzin? Okay.